Have you ever wondered how logistic regression works in machine learning? Well, let's dive into it. Logistic regression is a statistical method used for predicting binary outcomes. Yes, binary as in two outcomes like a yes or no, a pass or fail, a win or lose. For instance, consider an email filtering system. It needs to predict whether an incoming email is spam or not. Or, think about a medical diagnosis tool trying to determine if a tumor is malignant or benign. These are binary outcomes, and this is where logistic regression shines. At its core, logistic regression takes input data and calculates the probability of that data belonging to a specific category. It's like a fortune teller predicting the likelihood of an event. But instead of a crystal ball, it uses a mathematical model. So, with logistic regression, we're essentially trying to predict a probability that a given input point belongs to a certain class. And that's the first step into the world of logistic regression. But how exactly does logistic regression make these predictions? To unravel this mystery, let's first dive into the heart of logistic regression, the logistic function, often referred to as the sigmoid function. The sigmoid function is an S-shaped curve that maps any real-valued number to a value between 0 and 1. This is the secret sauce that allows logistic regression to make predictions. It's not about predicting exact outcomes, but rather probabilities. Now, you might be wondering, why an S-shaped curve? Why not a straight line or a parabola? Well, the sigmoid function is specifically designed to handle extreme values gracefully. When you plug in large positive or negative numbers, the output stays comfortably between 0 and 1. It's like a mathematical bouncer, keeping probabilities within the bounds of the party. But there's more to the story. To truly appreciate logistic regression, we need to talk about odds and log odds. Odds are a way of expressing probabilities, and they're especially useful when dealing with rare events. In the world of gambling, odds are everything. They tell you how likely you are to win or lose. In logistic regression, we're also interested in odds, but with a twist. We're not just looking at the odds, we're looking at the natural logarithm of the odds, or the log odds. By taking the log of the odds, we can work with a continuous spectrum of values from negative infinity to positive infinity, which is perfect for our sigmoid function. Now let's connect the dots. Logistic regression starts by calculating the log odds of the probability of an event happening, based on the input variables. This log odds value is then plugged into the sigmoid function, which transforms it into a probability between 0 and 1. This probability is our prediction. So, in essence, logistic regression calculates the log odds of the probability of an event happening, which is then transformed into a probability with the sigmoid function. So how does logistic regression fit into the world of machine learning? Well, it's all about predictive analysis. Logistic regression is a powerful tool used to describe data and to explain the relationship between one dependent binary variable and one or more independent variables. These independent variables can be nominal, ordinal, interval, or ratio level. Imagine you're trying to predict whether an email is spam or not. That's your dependent binary variable, spam or not spam. Now think about the independent variables that might influence this. It could be the number of exclamation marks, the sender's email address, or even certain words in the body of the email. Logistic regression takes all these factors into account, creating a model that can predict the probability of a given email being spam. This is why it's so valuable in machine learning. It gives us a way to make sense of complex data and predict outcomes. So, logistic regression provides a probability score for observations. So what are the key points to remember about logistic regression in machine learning? Firstly, despite its name, logistic regression is not a regression algorithm, but a classification one. It's a common misconception due to the term regression in its name, but it's crucial to remember that logistic regression is used for classification problems, not for predicting numerical values. Secondly, the dependent variable in logistic regression is binary. That means it has two possible outcomes. For example, it can be used to predict whether an email is spam or not, or if a transaction is fraudulent or genuine. Thirdly, logistic regression doesn't just predict a binary outcome, but the probability of that outcome. It gives us a value between 0 and 1, which we can interpret as the likelihood of a particular result. And that's the beauty of logistic regression in machine learning. Simple yet incredibly effective for binary classification problems.